Do you want to know how construction projects check and verify that they've been built correctly? Have you ever heard the term ITP or inspection and test plan and wondered what it meant? Well, this video is designed for you. My name is Tim and I'm a project engineer with lots of experience on the design and construction of major infrastructure projects. I've been building short courses to teach the fundamental construction management skills to engineers and other construction management professionals. So far, we've had over 1,000 students enroll in our courses. Each course is loaded with hours of content and practice activities to make sure you're equipped with the skills you need to excel at your job. This short video is an extract of our course on construction quality and completions management, where we'll talk about inspection and test plans and how to prepare and use them. If you find this video interesting and useful, check out the link in the below description to our complete Udemy course on construction quality and completions management. Hi, and welcome to section 3, where we're going to talk about inspection and test plans. An inspection and test plan documents all the inspection and tests we'll complete for a given construction activity. The construction activity covered will depend on what we identified in our work breakdown structure. Basically, an ITP documents everything we are planning on checking and what verification records we will be providing. This is a large section and there's a lot to cover, but it's critical we do this section properly as ITPs are fundamental to construction quality management and you'll have to manage and deal with them on a daily basis as a junior engineer. In this section, we'll cover what inspection and test plans are, the scope, structure and contents of an ITP. Then we'll talk about the process for developing an ITP, followed by a discussion of how to complete and close out ITPs. Finally, we'll go through an example ITP, followed by an exercise where you guys can have a go at drafting your own. An inspection and test plan, or ITP for short, is a document that describes the plan for managing the quality control activities of a work lot. Basically, we want to prove that the works covered in a given work lot comply with the design and ultimately project requirements for that work lot. ITPs are required for all significant construction activities involving handover to the client. ITPs need to be produced prior to works commencing. Although this is not always the case, they are typically produced by the engineer responsible for the works, but in some instances may be also produced by subcontractors. Following their production, they will then get checked internally by the project quality team before being issued to the client for their review and approval. As the ITP will document the ultimate verification and validation for the works completed, the client will review ITPs very carefully. The approved ITP will document all the verification and validation activities required, including test methods, documentation to be provided, any hold or witness points requiring sign-off. We'll touch base on these a bit more later. Frequencies of testing, and who is responsible for signing off and improving the final ITP. ITPs need to be completed as works are performed to ensure no testing or verification points are missed. Any failed tests that can't be rectified easily before works progress will result in an NCR being raised. So what scope will an ITP cover? An ITP needs to cover each of the individual construction activities identified in the WBS. Each lot will need an inspection and test plan created for it. The scope needs to be clear and definite. All major construction activities that result in something being handed over to the client require an ITP. Let's now quickly go through some examples of different construction activities we would have an ITP written for, and how often we would fill out a new ITP. I'll go through some examples of ways I've set them up on projects. For piling, we filled out an ITP for each pile. For conduit install, we completed a new ITP for every section of conduit from pit to pit. And for concrete works, we completed an ITP for every concrete pour. Once we go through how to develop an ITP, it may make a bit more sense how often to complete them. What about activities like traffic management and service proving? Well, typically you wouldn't need ITPs for these, as these are activities that facilitate construction works, but do not involve the production of a product that is handed over to the client. So how is an ITP structured? Well, depending on the company you work for, there will be some variety in how they choose to structure their ITP. Basically, an ITP needs to cover the following things for a given scope of works. It needs to sequentially list out all of the testing activities that will take place, a reference to the relevant standard of specification that requires this testing activity, the test method that will be used, the timing or frequency of testing, the acceptance criteria, and the responsible person for signing it off. The test activity will give a description of the work activity to be inspected and tested. What this is will depend on the stage of the construction activity, for example, survey set out, excavation, or during backfilling. The relevant specification will inform what specifications or criteria the activity is being undertaken in accordance with. So for example, when excavating for electrical conduits, clause 9.3 of AS 3000 specifies that electrical conduits must have a minimum of 500 mil cover. I just made that example up to prove a point, so don't go quoting me on that. So the test activity should be excavation, and the relevant specification would be clause 9.4 of AS 3000. Next, we need to list the test method. This is the method we use to complete the inspection. For example, to verify our trench depth, we may measure it with a tape measure. Other types of test methods may include visual inspection or forms of testing. The timing and frequency section specifies when and how many times the inspection must be carried out. For example, at 10% complete, every 100 meters of trenching, or maybe every day. Again, this will depend on the activity being undertaken. Additionally, if the ITP is written for a scope of works where there have been lots of errors in NCRs, you may elect to test more frequently. The verifying record specifies what recorded evidence is required to prove that the inspection and testing has actually taken place and the outcome of the inspection and testing. So for our trenching example, we may attach a photo to our ITP of a tape measure in the trench to prove the depth of the excavation. Alternatively, this may not even be required, and we could just tick to say we had indeed inspected the works and verified the trench depth. Finally, the responsible person section nominates all the relevant authorities who need to have inspected and approved the activity. There may be multiple individuals responsible for checking, including the subcontractor, a representative like us from the contractor, the client, or even other third parties, such as an electrical inspector. In this section, we'll need to nominate if it's a hold point. This means works cannot proceed past this point without the relevant approval. So for example, the client may nominate a hold point to inspect the steel reinforcement prior to any concrete pour, or it may just be a review point where works can proceed without the responsible person approving them. In between these two is a witness point, where the responsible person needs to be notified, but can choose not to attend the inspection when informed and works can proceed. That basically covers the contents of an ITP. Again, between different companies and projects, the structure and template will change, but all of them should address these key points. Now we're familiar with the structure of an ITP, let's now look at the contents. This is the information we'll actually populate the ITP with. To begin with, the ITP needs to follow the method statement. This is the methodology used to complete the construction activity. Against the methodology, we will then identify the testing and inspection and records associated with it. In general, any construction activity will follow a methodology like what I've got on screen. The first step will be to review the design. We'll check the drawings and specifications for errors and constructability issues before issuing them to a subcontractor. Next, we need to check that the materials supplied to complete the task are correct. We'll check approved materials have been procured, factory testing completed, delivery dockets are provided, and type approvals have been completed. Any mock-ups or examples have been approved and that they have been stored correctly. Next, we'll check that the worksite is ready for that specific construction activity to commence. We'll check that any previous trade has completed their works correctly and our works are ready to commence. We'll ensure previous trades have completed their QA. This step is critical and has commercial implications. If we tell a trade to start works and a previous trade is not fully completed, then we may be liable for contractual claims if the works were not completed correctly. We'll also need surveyors to mark out the works providing heights, dimensions, and any additional information from the design. It is critical to ensure that the works are set out correctly and that the surveyors are using the correct set out files. Once all of these checks are complete, construction can commence. This will require detailing any testing and inspection required, depending on the construction methodology and relevant specifications. Any hold, witness, and inspection points will need to be identified. When works are complete, there will be checks to make sure that any as-built documentation has been collected, such as survey pickup of conduits. For example, when constructing piles, survey may record top of piles so that this can be provided to the structural steel fabricators. Additionally, any testing to ensure that works are being completed correctly will be conducted, followed by a handover to other trades or commissioning. This is the general methodology used to manage works, and will change slightly depending on the works being performed. For example, for electrical works, you likely won't need as much survey input as for civil works, but electrical works may require more checks that the correct materials are being used. Now let's go through how to actually develop an inspection and test plan. The first step in developing an ITP is to identify and review the key inputs. We'll look at the WBS to review what the scope of the work activity we're writing the ITP for has to cover. Next, we'll look at the methodology for the works. This will be developed in consultation with subcontractors and workforce during planning. We need to identify all the steps in how the construction activity will be conducted. We'll review the design to look to identify all the depths, dimensions, products we have to use, performance requirements, and so on. Finally, we need to review any relevant specifications, whether these be client specifications or statutory requirements. By the end of this stage, we need to have identified all the steps in carrying out the construction activity and all the requirements from the design and specifications. Now we can begin writing our inspection and test plan. Each activity in the method statement, as well as covering all the key points such as design, survey, handover from previous trades, material checks, and so on, as we spoke about in the last section, will become our test activities. We can populate these in the left-hand column of the ITP structure. Next, against each of these activities, we'll need to complete the remaining columns of the ITP. So we'll need to identify the relevant specification, test method, timing, and frequency, acceptance criteria, and any hold, witness, or inspection points relevant to that test method. Once this has been completed, we can now get our ITP approved. Firstly, we'll submit this to the internal quality team, who will do their own checks, ensuring that all criteria from the design and specifications are documented in the ITP. Once they are happy with the ITP, they'll submit it to the client for their review and approval. The client will typically make several comments, usually listed in an Excel spreadsheet that you'll have to respond to by updating the ITP or proving that the requirement they're asking for is not in fact required. You'll then need to submit your comments back to them, and once this back and forward has been completed, your ITP will be approved and you'll be ready to start your works. Make sure you allow enough time for this review process to take place. I've seen ITPs take up to 6 weeks to get their final sign-off from the client. Usually, there will be contractual timeframes that the client must respond within. However, depending on how long it takes to close out the review comments, the process can be long and unfortunately very painful. Inspection and test plans should be in place before any works commence. They then need to be completed progressively as the works are conducted. There is a tendency for ITPs to be completed after works are completed. However, this can result in a game of catch-up and missing important hold and witness points. Tests may be missed and important quality issues not identified. The photo on the right-hand side is from a rail project I worked on. It shows a draw rope that had been installed in a conduit and not spliced together correctly. When the cable haulers were pulling cables, the poorly joined ropes kept breaking, resulting in the cable haulers having to re-rope all the conduits, causing us delays and variations from subcontractors. ITPs help us to identify issues as they arise, when they can be easily resolved, ultimately avoiding costly errors and rework. We ensure things like survey set out are done correctly and there is a smooth handover between trades. Imagine building a concrete plinth and forgetting to get compaction results. We'd either have to wait and see if the plinth starts to sink in the poorly compacted soil and become damaged, or jackhammer out the entire plinth and recompact the ground. On top of this, the completion of ITPs will have a number of commercial implications. They can be a useful tool when managing payment for subcontractors, only paying subcontractors for the works they have completed, and properly closing out the QA. ITPs will typically need to all be completed before a contract can be closed out, and they can also be a good tool for managing defects and back-charging subcontractors for defective work. ITPs also support the overall project completions process. The progressive completion and handover of quality avoids rushing at the end to sign off all of the ITPs at once. They can ensure the client is familiar with the works taking place and any quality issues are picked up as they arise. Ultimately, the progressive completion of QA will avoid any failures to meet practical completion. Let's now go through an example process of preparing an ITP. Going through the step-by-step process we identified in the previous section, developing an ITP involves 3 steps. Firstly, we need to collate all the inputs. Next, we need to prepare the ITP. And finally, we need to get it approved. We're going to run through this example for the installation of a section of underground electrical conduit. So, step 1 is to collate all the inputs to the ITP. These are the requirements we need to clarify and reflect in our inspection and test plan. The first major requirement we'll look at are the design drawings. As an example design, I've done a really quick mock-up of an example trench design using PowerPoint. Although I don't think I'll be getting a job as a drafter anytime soon, this simplified mock-up has all the key design details. The design shows a cross-section of an electrical trench showing three 100mm electrical conduits surrounded by bedding sand. The conduits are 600 below finished surface level. 250mm below finished surface level will be marker tape. Next, we'll look at the governing specifications. For the purpose of this exercise, I've made up a few example specification requirements we'll need to follow. We have the below requirements for these works. We'll need a permit in place to excavate. We need to be using approved materials. Compaction testing is required. And at the completion of the conduit installation, we need to manual test the route, as evidence that the electrical cable we install will be able to be pulled through the route. This will be a hold point where the client will need to sign off the manual testing has been completed. Also, we need to understand our methodology for doing the works. These are the steps we're going to complete for the task. For the installation of an underground electrical conduit, we'll do the following. First, we'll excavate the trench. Second, we'll lay conduit in the trench and glue it together. Next, we'll backfill around the conduits with bedding sand. Then backfill up to 250mm below finished surface level and lay marker tape. Finally, backfill up to finished surface level and compact. Finally, we'll complete compaction testing and mandrel testing to prove that the works have been completed correctly. Now we understand the design, the governing specifications and methodology, it's time to actually write our inspection and test plan. In step 2, we now need to fill out our ITP structure based on what we identified in step 1. I've attached a copy of an example ITP I completed to cover this scope. I created this ITP using the steps I went through earlier. I began by completing a high-level structure based around the pre-works checks we would need to conduct, procurement of materials, the actual construction activities, any testing and closeout. Next, I elaborated on the detail under each section. So for pre-works, we'd need to check the design to make sure the subcontractor has the right drawings and any approved RFIs or design changes. All applicable permits are in place, the works have been marked out by survey, and there has been a structured handover from any previous trades. The important, critical activities will be reviewed by a project engineer, while the site engineering activities, such as survey set out, will be reviewed by the site engineer. The supervisor will check that the work area is clean and been handed over properly from previous trades. Next, we'll make sure all the correct materials have been procured. So to install underground electrical conduits, we need conduits, marker tape, and backfill material. We'll need to ensure all these materials have been approved and are correct, and we'll verify this by collecting any delivery dockets. Next, we'll list out the construction methodology under the construction section and note any checks we need to complete against this. Basically, to install underground conduits, the construction methodology is to trench to the correct depth and width, install conduits, backfill and compact, install the marker tape, and finally the draw rope. Against each of these items, I've listed checks that we will need to do and evidence that will be recorded. For example, to ensure the trench is dug to the correct dimensions and depth, we'll get survey to check the depths prior to conduit installation. To ensure the conduits have been installed correctly, we'll get a photo of the conduit arrangement every 20 meters. Section 4 lists any applicable testing that is required on the completion of the works. For our conduit installation, we'll complete a mandrel test on completion of the works. Mandrel testing involves pulling a large plastic ball through the conduit to ensure it is free from debris and cables can safely be pulled through the route. As records of this being completed, we'll record a video of us completing this test. Finally, once testing is complete, we'll need to complete the activity closeout requirements. This will involve marking up the design with any required design changes, the process known as redline markups, as well as ensuring the survey and digital engineering team have captured all the as-built data. Now our ITP has been completed, we'll need to submit it for review. The first stage of review will occur internally, when we submit our ITP to senior project engineers and the internal quality team. They'll complete their own checks to ensure it covers all necessary checks. Once they are happy, it will get submitted to our client. They will complete a thorough review and likely make a number of comments we'll have to action or prove are not necessary. Any updates to the ITP will be submitted back to the client, and this back and forward will continue until all parties are happy with the ITP contents. Now we've got our approved inspection and test plan, and we can begin works. While this was a long section, as a junior engineer, you'll be heavily involved with the development and completion of ITPs, so it's actually a super important topic. Next, we're going to look at commissioning, another important quality control process.